We did the bit shift left and the bit shift right. This is the bit shift grand finale. The next section of the lab manual was entitled BSL and BSR, length greater than one word using database viewing. Database viewing, that's what this rung is right here, or rather, we would have to drag open our Explorer there and bring that up. Now we can pull this back over, go back to Window, and go back to our logic. But if we want to look at the data table, we can always go to Window, Program Tags, Window, Main Program. I told you to edit the length of both the bit shift left and bit shift right instruction to 35. And I made them equal length because I wanted to demonstrate the difference in the behavior of these two instructions. Now keep in mind, they don't have to be the same length. If I want to do something really tricky, I could have the length of one shorter than the other, and it would just be a matter of where the source bit gets inserted into the shift. And there are instances in real life, if you're going to use these instructions, where you might do something like that. We won't have one in this volume. This is a beginner plus. That would be a much more advanced approach to using bit shift left and bit shift right instructions. With any array 1 as the array, as you can see here, any array 1, element 1 is the array, and bit 0 of any array 1 is one of the boundaries. The other boundary would be 32 bits to the more significant direction, meaning if I go and look at my tags here and I expand any array 1 and any array 2, I don't know if I can get them all in here or not. Yes, I can. There's any array 1 bit 0 and there's any array 2 bit 2. These 32 bits plus these 3 bits 0, 1, and 2 of any array element 2, that is your shift field. So we're going to shift bits, all these bits back and forth in these two words, but still within the any array itself. With the new length of 35, what bit is the first bit of the shift for a BSL? Well, it's element 1 bit 0, which is the last bit. Element 2 bit 2. For the BSR, what is the first bit of the shift? It's going to be, because we're going back the other way, it's going to be any array 2, element 2 bit 2. So this is our expanse here from any array 1 bit 0 to any array 2 bit 2. Now remember, this is in the 3 double integers, this would be the next lower bit from this bit. It would be element 0 bit 31. And this would be the next higher bit from the highest, which would be bit 3. So 23 and 031 represent the next bits from the extent out of our shift range. Considering the structure of any array, what is the maximum length that you could specify? Not that we did specify that, but you could specify. That would be 96. Why is 96 the limit? Well, you only have 96 bits. You can't shift any more than 96 bits. You can't shift from without of that 3-digit double integer. This isn't like the old days where if you picked 3 elements inside of an array, and we're not going to go talk about all those old arrays back with PLC 5 and SLC 500 micrologics, and let's say you had a file B3 0 through 20, 21 words, and you're going to work with 16, 17, and 18. Well, there is a 15 and there is a 19. And you had to be careful what you did with your boundaries back then. In this case, we've got 3 double integers, and nothing can happen outside of those 3 double integers. If you load a bit at bit 31, we'll go to, if you load a bit at bit 31 of any array 1, right there, how many positions are there to the right of any array 0.0? Now we don't have 0.0 exposed here, and we can't get them all in this vertical space. But if you have a bit loaded here, then you have 30 through 0 and then 31 through 0 of any array 0. So that would be 63. Loading at bit 0 of any array 0, how many would you have to the left? Well, you would have 63. It's not 64 because out of the 64 bits you are already in one space. So that gives you 63 to the right or 63 to the left. Then I had you add some clear instructions, and I see I don't have those in there, so I'm going to add them right now. I'll put this in the edit mode. I'm going to click on that instruction. I'm going to go Control C, Control V, Control V. So I will make this just to put them in logical order, 0, 1, and 2. Finalize all edits. Considering that this series of manuals is both an introduction to programmable controller programming and RS Logix 5000, we take every opportunity to exercise the graphical user interface, integrating its features with the demonstrations of the instruction set. So open the program tags database, expand array 1 and 2 as shown in the manual. Back to Window, Program Tags, and we're showing 114 at the top. So we can scroll down to 114 at the top position, and we show 27 at the bottom right here. We have more vertical space here than what we showed in the manual. Now we're doing this so you can watch these bits. What is critical to this demonstration is you're being able to view the last few bits of 1, which would be these right here, 27, 28, 29, 30, and 31, and the first 5 bits of 2, 0, 1, 2, 3, 4. So you can see the shift. Don't forget that you have an output that energizes with an on state for the first bit and the unload bit, but you're going to ignore the other 2 outputs. If we go back to our logic here, you can see that we no longer have these bits, all of them assigned to something relevant. Now that is relevant, so just for grins, I didn't have you do it in the manual. I'm going to change that to last array bit with a slightly different tag name. That will allow me to re-alias it to 2, which is the last bit. I didn't have you do this in the manual, maybe I should have, but this is the first and the last array bits because we have 35 bits from 1, 0 to 2, 2. Set the source bit switch to the on state. Make sure everything else is reset. So put the source bit to the on, which is input 1. Toggle your enable bit shift left switch on off 3 times. So the bit shift left is input 0, 1, 2, 3. You see we sucked in from the source bit into bit 0, then moved that to 1, then moved it to 2, and so forth. We have 3 bits in there in series. Now the reason we're doing this because it's easier to see 3 bits moving through the array than it is a single bit. Set the source bit switch to the off state. Toggle your BSL enable switch off on until you see the group of bits first appear at the top of your database view and then stop momentarily. To do that, we have to go back to Program Tags. So now I'm going to do the bit shift left, which, if you remember, bit shift left is 0, right is 2. Okay, so we're watching in here for the ones to first appear. We start our bit shift left. Click, click, click. There, I got one at 14, 15. You see followed up by the 0, so 15, 16, and 17. Continue then shifting it to the left, which is down, until the leading on bit has shifted into the last bit of element 1, which would be bit 31. It's easy to overshoot. There. Our leading on bit, this on bit right here, is in the last position of that element. But it's not in the last position of our shift field, which is 35 bits. Enable the bit shift left one more time. So watch going from 31 to 20. Now this one right here doesn't count because that's the value of all 32 of these bits in decimal. So that one does not count. Looks like there's 4 there, but there's not. There's only 3. That one does not count. Just keep that in mind. And in the manual, I had a little graphic there to show you what this bit pattern should have looked like. Then toggle the bit shift left until the leading on bit shifts into the bit location that you have decided is the last bit under the influence of the bit shift left. Now see, to me that's the last position. When we shifted from 31 to 0, that went from 32, 33, 34, 35. That's the 35th position. Now let's go back to our logic, and you see that the last array bit is on. And you see that the first 3 bits of any array element 2 are on. Okay, now remember, I didn't have you do this in your lab project, but if you want to do it over and change your little HMI string of bits here, you're welcome to. Did the to the left unload bit energize the output? No, because the last thing we did was we unloaded a 0 from this position into the unload, the left unload, before we moved 1 to 2, 0 to 1, and so forth. Enable the BSL one more time. Did the to the left unload bit energize the output? Yes, it did. Does the unload bit energize when the on bit is shifted into the last bit of the shift field? No. Or when it leaves the last bit of the shift field? Yes. Toggle input 5, whatever you have in your logic to clear the array, toggle it. And that would be 5. So if you look down here at the bottom, that's our reset clear. So I'm going to push that on, and that clears everything. If we go up here and look in our tags, I will collapse these back down so you can see them all. So you see all 3 elements are 0. Back to the logic. Now I think I'll do one more thing that I didn't do in the manual. Well, 2 things. One, I did tell you to add bits to unlatch, but before we do that, it did ask you the question. We toggled input 5 here, and we cleared the array, but did the unload bit clear right there? No, it didn't. Add logic to clear the unload bits when you clear the array. So I'm going to put this rung in the edit condition. I'm going to select the clear instruction, and I'm going to have to bring back, go to View, Toolbars, Restore Factory Tool Layout. We'll just go back to that. And I wanted to, at the end of this rung, I wanted to add 2 unlatches, and then grab that tag and this tag and drag them in there. Also, I wanted to change this tag to reset clear. Oh, we can be clever and put push button in there too. Why not? But I have to create it because it's a new tag, and I want to alias it to local 1 data bit 5. And then finalize all edits. Okay, now when we push the clear button, 5, you see it unlatches the unload bits. Drag this back over, and we are missing the bottom next bit past the last bit. You know, we don't need that bit anyway. It's no longer relevant because this would be that bit right there. Any array 2.3. Okay, we'll just do that. Any array would be 3. 2 is the last bit. Next bit past the last bit would be 3. Finalize all edits. That way this light turns on and it means something. However, it's very difficult to see all of this logic with it geezered up like that. And I know some of you may be watching this on a smaller screen, and right now it's hard to see, even though I can see it perfectly fine on my 27-inch high-def monitor. I'm going to geezer it back up and forget about that last rung down there, as long as we can see the unload and these rungs. We're doing fine. You should still have the program tags in view in your display. Go back to here, program tags, and we have to drag this down, and we had it something like that, like 14 at the top. Where did the bit load when the on state? Put the source bit into the on state. You can't see that, but if we go back to the logic, the source bit is on, and then go back to program tags. With the source bit in the on state, enable the BSR once. Well, the BSR is input 2, so I enable it once, and then the question was, where did the bit load? Where did the on state appear? It appeared right here. Remember, these were all zeros. So it appeared any array element 2 bit 2. That's the answer to the question associated in your manual, roughly step number 13. That may change, but roughly step 13. Enable the BSR 2 more times to put 3 consecutive on bits into the shift field. Once more, once more. These 3 bits, because they're bit 0, 1, and 2, that's a binary 111 is a decimal 7. So always ignore in our labs here this value. So if these shift, we're going to see them go to bit 31 next. Return your source bit to the off state, then enable the BSR repeatedly at a rate that you can watch the on bits shift towards the unload position, which would be towards the top of the screen. So watch those 3 bits there. See the 7 went to a 3, went to a 1, went to 0. So you see the 3-bit pattern shifting towards the top of the screen. When we get there, I'm going to scroll down, and I will expand element 0, so you can see now there's your 3-bit pattern. Look at that decimal value. So these 3 positions, binary, would add up to 229,376 in decimal. Now we really don't care about that value, we only care about the bit positions. Okay, what is the last position for the bit shift right? Well, that would be 10. When you get to the last position with n on bit, stop. We're going up here, and when the first one, the leading one, 3, 2, 1, 0. Now I just heard a light come on. If I go to my program, that's the first array bit, bit 0. What memory location is the last bit in the shift field for the BSR? Well, we said that. Element 1, bit 0. Did the unload bit energize? Yes and no. The on state didn't because it's not there yet, but it did unload a 0 into the unload bit. Always keep that in mind, that we're not just dealing with ones, we're dealing with zeros. The unload right now has a fresh 0 in it, even though it was 0 before, it's still 0. It did not change state. Should it have energized? No, because when you transfer a 0 into the unload bit, it stays unenergized or de-energized. Enable the BSR one more time. Did the to the right unload bit energize with this shift? Yes, it did. You can see down here to the right unload is on. Be careful which switch you operate now. Enable the BSL one time. We were doing right, now we're gonna go left. So watch these two bits right here. And remember, this bit doesn't count because it's in the element 0, which we're not even using. But I put it there so you can see this doesn't go in, it doesn't transfer into there. It unloads and otherwise goes into bit space. Enable the BSL one time. That'd be bit 0 right here. So now you see that 2 shifted to 3, 1 to 2, 0 to 1, and so forth. And somewhere way up the line here at bit 2, that 0 unloaded into the to the left unload. But see, you don't see anything because it was already off and it went to another state of off. So you didn't see the change. Did the BSL retrieve the on state that the BSR exercised off into bit space back into the array? In other words, we did have a 1 here. We shifted it, it turned on the unload bit, then we went backwards, left. And the question is, did that bit that left here into the unload go back there? No, it did not. Change the source bit switch to the on state. Flip that on. Source bit's on. Enable the BSL 3 times. The BSL, that's the bit shift left. 1, 2, 3. And let's go to our memory. Okay, you see we have all 5 of these bits now. You didn't see them in the logic because remember, we go from, this was 0, well, we had 0, 1, 1, but when we went 3 times, it shifted 3 to 4 and 4 to 5 and so forth. So you only see the 3 most recent bits shifted into the left. But if you go to the data table, so there's those 2 on states we already had, and they shifted 3 places from 1, 2 to 4, 5. And so in the manual, I show you an image of the data table here, and you see it matches. The bit pattern matches, and just as importantly, the value of any array 1 is 55. That's a quick way to check to see that they match. Now, if it doesn't, you need to go back and do this all over again because you made a mistake somewhere. And it is very important that you understand the behavior of the bits in your data table when you're using the bit shift instructions. The idea is learning, not completing each lab with no mistakes. The idea is to learn, not just to get it done. Just for grins, while you are here, you can play with the bit shift left and right for a while, clearing the array to start clean if it gets too muddy for you. Okay, now I had you, and I'll go back to the logic, and I had you clear the array and the unload bits. So I'm going to scroll down here so you can see this wrong. I'm going to push input 5. You see that's true, so it clears all 3 elements and unlatches any unload bits. Okay, and I had you save this project as bit shift final. And I remind you again to be sure you clear it.